We are given this matrix A, and we know that A has eigenvalues lambda 1 equal to lambda 2 equal to 1. And we consider the initial value problem x prime equal to A times x at 0 equal to 4, 2. We need to find x at 1. So we first need to solve what is xt is 5 xt, the solution of this problem, and then you plug in t equal to 1, you get x of 1. We use eigenvalue methods to solve this. So we know the two eigenvalues are 1, the repeated eigenvalues case. So now we find the eigenvectors. So the eigenvectors v, so v is an eigenvector, v is non-zero, v is in R2, v in R2 v is non-zero, such that A minus lambda I, in this case I call lambda equal to lambda 1 equal to lambda 2 equal to 1, lambda I times v equal to 0. So we solve that. A minus lambda I, A minus 1I, v equal to 0, because lambda equal to 1. This is our matrix A minus 1I. So we put minus 1 there. Minus 1, minus 1. The matrix we get is 1 minus 1, 1 minus 1. So if you do row reduction, you get 1 minus 1, 0, 0. Let me say vector v is have two components a, b. So we have 1 minus 1, 0, 0, ab equal to 0, 0. This one equivalent to a minus b is 0. So vectors ab, vector v, is vectors with a equal to b. So a times 1, 1. So any vectors of the form a times 1, 1 or a need to be different from 0 so that our eigenvectors is non-zero. So this one, the vector of this form as eigenvectors. So we choose v to be vectors 1, 1. We only have one linearly independent eigenvectors. So in this case, you need to find the generalized eigenvectors. We find a generalized eigenvectors. Let me call this vector v1 and we find v2. v1 equal to a minus lambda I times v2. So on methods you can solve this one, solve this equation. You know v1 is, you know what this matrix is, you can solve for v2. v2 is a solution of this equation, or else we know that a 2 by 2 matrix, in this case lambda is defective, a minus lambda I square equal to 0. So v2 a minus lambda I square v2 equal to 0. This v2, you can choose v2 to be anything. So choose v2 independent or linearly independent from vectors v1 from 1, 1. So I choose v2 to be 1, 0. Now I update v1. v1 equal to a minus lambda I times v2. so that we need to make sure that this v1 is non-zero. A minus lambda I, we did compute it before. This matrix times v2 times 1, 0. So because we multiply 1, 0, we will get the first column. v1 is 1, 1. So it is exactly that v1 in this case. Usually it can be different from this. It can be 2, 2, 3, 3, or a for other a. But this is our v1, the ordinary eigenvectors, and we have v2, 1, 0. Now we construct the solution. General solution of the equation x prime equal to a times x is, say, xt c1 on v1 e lambda 1t. In this case, because we have only one ordinary eigenvectors, and then the other one will be generalized one, c2 v1 t plus v2 times e lambda 2t. So e lambda 1t is the same lambda here. So in this case, lambda 1 is 1, lambda equal to 1. So c1 v1 is 1, 1. E power t c2 v1 is 1, 1, give us tt plus v2 plus 1, 0 e lambda t. So you can group e power t out there. Inside you have c1 times 1 plus c2 times t plus c2, c1 plus c2t. So this is our solution xt, the general solution. Now we find c1, c2. We know the initial conditions. So our initial condition is x0 equal to 4, 2. So x0, you plug in t equal to 0 here, you get c1 plus c2, c1 e power 0, so which is 1. This one equal to 4, 2. This one gives us c1 equal to 2, and therefore c2 equal to 2. So we know that the solution of the initial value problem will be xt is when c1, c2 are 2. 2 plus 2t plus 2, 2 plus 2t. Now we need to compute x at 1. You plug in t equal to 1. 2 plus 2 plus 2, 6, 4, e power 1. So this is 6e, 4e. This is our final answers.